Hey guys, so today we're going to start our chapter over proofs, and of all the things we cover this year, this is one thing that for sure you're going to use every day in your lives. Proofs are going to help you to think logically, which thinking logically means like being able to analyze a situation and coming up with sensible solutions while using your reasoning skills. So let me talk to you about a very real life scenario. Let's say you just saw a picture of your best friend on Snapchat with her arm around your newest crush, okay? You freak out, okay? You want to rip up all your pictures. You want to destroy your matching necklaces and bracelets, whatever. Live it. But then you slow down and you start to think logically and you say, wait a second, I just started having a crush on this new guy last night. I don't think I've told her yet. She's always been super respectful to me. She's never crossed the line before. I think she's neighbors with this guy, so maybe they were just out and about and ran into each other. Okay, I think I'm going to just talk to her about it tomorrow. So, as you can see from just that very real life scenario, you went from super angry, but your reasoning skills, your logical thinking allowed you to bring yourself down, to think sensibly, and to make a good choice that didn't destroy a friendship. So hopefully you're thinking, yeah, that literally just happened to me. No, I'm just joking. But really, this is important. So, okay, so you're probably thinking, what is she talking about? A two-column what? So throughout this chapter, you are going to see all of these proofs are going to be set up like this. On the left, you're going to see a statement. And on the right, you're going to see a reason. So why do they call it two-column? Well, you will literally draw two columns. Just says some housekeeping. You are going to number each of your statement and number each of the reason that corresponds with that same number. I don't want number one up here, number one down here. They should be right in a horizontal line. And then, for example, 2 and 2 would be right in a horizontal line, and so on and so forth. These proofs can have 3 reasons up to 37. I mean, we won't get any that big, but there are very large proofs out there. So yes, and keep in mind that your proof may have 6 steps where mine has 8 and your neighbor's has 7. It's not like something else in math where it's like, oh, this is the right answer and this is the wrong answer. There is room for creativity, and that's why I really enjoy this chapter. So in that right side column I talked about right here, there's reasons. Today, our reasons are going to come from this chart. On your weekly calendar, right underneath the target, you see proof reasons. That is a compiled list of everyone that will use this chapter. Here are the ones we'll just simply use today. So the reflexive property. The reflexive property is when you have something equal to the exact same thing. For example, LS is congruent to LS, or 3 is congruent to 3. I've always remembered this because it reminds me of seeing my reflection in the mirror. And reflection kind of sounds like reflexive. I know it's a stretch, but that's how I've always remembered it. Symmetric is, and I've always remembered symmetric by same equation, it's just flipped. So here's 2x equals 6. If we flip it, we have 6 equals 2x. Or 2 equals 3. If we flip it, we have 3 equals 2. So that's symmetric. Transitive property. I always remember transitive as take out the middleman. So for example, if I am over here If I have x equals y and y equals x, well, look, here's that matching middleman, that y. We take him out, and we're left with x equals z. Or if in a geometry example, angle 1 equals angle 2 and angle 2 equals angle 3, if I take out that matching middleman, then I'm left with those angle 1, angle 3. So transitive, take out the middleman. The rest of the properties I think you'll remember from Algebra 1. If I have 2x minus 6 equals 4, I would add the 6 to each side, and I'd be left with 2x equals 10. That's just the addition property. If I have angle 1 minus 30 equals 90, and I add 30 to each side, again, that's addition property. For subtraction, same thing. If I subtract the 6 from each side to get 2x equals negative 2, that's subtraction. Or in this case, if I subtract the LS from each side, actually, let me write this one because this one's kind of weird to see. But if I subtract the LS from each side, those cancel, and I'm left with SU equals UP. So subtraction can work in that traditional algebra sense or when we're subtracting segments. Same with multiplication or division. Multiplication and division are actually, they can be substituted for each other. So you could have either answer. And the reason is, if I have 2x equals 6, I think most of us would divide each side by 2 and use division property. But some of you may multiply each side by a half, which is the same thing. So that would be, again, multiplication or division. Same thing over here. I could divide each side by this 2 or multiply each side by a half. So that's why multiplication and division are interchangeable. Distributive property. You've seen this before. If I take 2 times x and get 2x and 2 times 3 to get 6, that's just called distributive. And finally, if I have that x equals 2, I can take x equals 2. I can take that 2 and plug it in for x, and I'm left with 3 times 2 plus 1. We've done that quite a bit this year. When we get x equals a number, we plug it in to get the measure. So that process of plugging in is called substitution. You will see it also with geometric examples. So if angle 1 equals 130, I can take over here angle 1 and replace it with 130 to be left with 130 plus angle 2 equals 180. So these are the reasons. These are what we'll use in the right side of our column. So let's start our very first proof. These are algebraic proofs, and they're the easiest type, but it's a really great way to introduce you to that process of writing a two-column proof. So there's 2 ways of writing an algebraic proof. There's a long way and the short way. You do need to be aware of both ways because the air test may use one or the other. I've even seen proofs where they've kind of used a combination of both. So we're going to do this one the long way, and the next one we'll do the short way. So any proof you start, you are going to start with the given. So it says prove that for negative 5 times x plus 4 equals 70, then x equals negative 18. So what the given is what we start with, and what we're trying to prove is what they end with. So let's start with this given. Let's literally just copy it as it is. And again, notice I numbered number 1. And then over here, I'm going to number that 1 given. Okay, and then I'm also going to draw my column. Okay, so in my second step, you will literally just do what you would do next to solve this equation. I think most of us would distribute. So I'm going to do negative 5x minus 20 equals 70. And guess what my reason is? It is distributive property. In the third step, what would you do next to solve this equation? And hopefully you're saying, well, I'd add the 20 to each side. So I'm going to do that. But here's the thing. I have to show it in my proof. And I know that makes a lot of you uneasy. You don't like showing work. But that's the whole point of these proofs, is to show step-by-step logical reasoning why x equals negative 18. So I just added to each side. So I do not like that I just made those out of line. I really want these in line. So I'm going to just fix that. I'm going to go right here. And my reasoning was the addition property. So I'm just going to write addition. So I hope you're noticing, wow, she's kind of picky about how you line these up. You better believe it. When you are grading hundreds of these proofs and they are not lined up, it is rough, let me tell you. Okay, next, I'm going to write what that simplifies to. So when negative 20 plus 20 cancel, I'm left with negative 5x equals 70 plus 20 is 90. Now, this is kind of unusual, but anytime you simplify a proof down, you are going to use the property substitution. Because we are replacing, basically right here, we replace what 70 plus 20 equals, and we replace it with 90. So that is substitution. Step 5, what would I do next to each side? Well, I would divide each side by negative 5, and again, I know it makes you want to barf to show this work, but that's what you got to do. Okay, so next I'm going to justify that. What did I do to each side? Well, I used the division property. And then finally, in step 6, I'm going to write what that simplifies to. X equals negative 18. And listen, if you don't get what you're trying to prove, you did something wrong, and you're going to have to go back up and find that. But, again, what is that process of replacing what 90 divided by negative 5 is? That is substitution. Okay, good. So that is our very first algebraic proof, the long way. So let's do one the short way. All right, so it says prove that for 2x minus 7 equals negative 3x plus 8, x equals 3. So again, let's start any proof, you start with the given. So let's go over here to step 1, and let's just recopy what we're given. We're given that 2x minus 7 equals negative 3x plus 8. And our reason is given. So I always tell kids, I'm like, at least you should get 1 point on every proof because you know to start with the given. So that should be an easy one. Okay, so again, we're doing this the short way. So in the short way, you would, okay, let's take the little brother over the big brother, but instead of showing it, you would just do it. So if I added 3x to this side, I'd be left with 5x minus 7 equals, and if I add 3x to this side, those would cancel, and I'd be left with 8. I don't love that I just wrote that all the way over there. Not that it's a big deal, but it's going to bug me. Okay, so what did I just do there? Well, I just added the 3x to each side, so I'm going to use the addition property. Okay? In step 3, what would I do next? Well, I would add the 7 each side. But again, instead of showing it, since this is the short way, I'm going to add 7. And I'm left with 5x on the left. 8 plus 7 is 15 on the right. And that is addition property. And then in my fourth step, what would I do? I would divide each side by 5, and instead of showing it, I'm just going to do it. And I'm left with division. So I'm sure a lot of you are breathing. He's like, oh my gosh, I love that. I'd much rather do that. That's cool. But just know that if the air test does the long way and using that substitution in every other line, that you're prepared for that. Good. So this next proof, listen, I'm not trying to freak you out, but this is kind of where we're going. And this proof, I really like it. It kind of gives you a nice little bridge into geometric proofs. But this is honestly what you're going to see most often is this traditional given prove. So there's no question like the last two examples, like, okay, what's our given? What do we prove? It's pretty straightforward. So, without even thinking about anything, I'm going to go ahead and start with my given. Angle FGH is congruent to angle JGK. And angle JGK is congruent to angle KGH. And the measure of angle FGJ is equal to 6x plus 7. And the measure of angle KGH equals 8x minus 5. And all of that, my reason is given. And let me be very upfront with you. You don't have any like this tonight. This is just a cool, again, eye-opening example to what you're coming up to. So when we get to these geometric proofs, anytime you have congruency statements, you have to change them to equations because you're going to be plugging them in and out of equations, and in order to do that, they have to be in an equation already. So it's kind of like a cosmetic thing. Change these congruency statements to equals and put a little measure in front of it. So this congruency statement would go from measure of angle GJK equals the measure of angle KGH. And that reason, we haven't talked about this, but we'll talk about it more, is just definition of congruency. All right, so the next thing I'm going to do is, since I'm in the algebraic business right now, I want to get these algebras into the proof in an equation so that I can solve them. So how the heck do I do that? Well, this is kind of interesting. Do you see right here where we have GJK? That is a like middleman, and we're going to cut him out and equal what's left. So I'm going to do just that. In my step 3, I'm going to take the measure of angle FGJ and equal it to the measure of angle KGH because, again, I cut out that middleman. Does anybody remember that property we covered? That is middleman. Cut out the middleman. It is transitive. Okay, next, what that allows me to do is plug in the algebra. So what goes in for FGJ? Well, it's equal to 6x plus 7. What goes in for KGH? Well, it's equal to 8x minus 5. And what's that process of plugging in? It's substitution. Okay, I want you now to pause this video and finish this algebraic proof and then check back with me when you're done. All right, sorry, mine's a little sloppy. I had to really cram it in there, but I purposely did something because I wanted to talk about this. I chose to get the little brother to the big brother here. So I had my x's on the right side. So I was left with 6 equals x. The proof wants x equals 6, and you may think that doesn't matter, but in the world of proofs, it does. So in step 8, which kind of got cut off, I had to just flip the equation to x equals 6, and that reason is symmetric. Remember that reason, same equation flipped. So if you ever come in contact with that, that's what you have to do. So good. I hope that was a good little introduction to algebraic proofs. You are now going to work on identifying some of those properties and filling in some algebraic proofs. Great job today. See ya.